2.4, the first thing we're going to talk about today is a biconditional statement. And a biconditional statement, that's going to be important. That's why I underlined it. So you can either underline or you can highlight that part. Okay, so a biconditional statement is a statement that can be written in the form P if and only if Q. Okay, so P if and only if Q. What is the P?
The hypothesis.
The hypothesis, and the Q is the conclusion. Okay, so this is going to be a different form. Before, we just had conditional statements. Do you guys know what form we'd say conditional statements are?
P then Q.
If, yeah, and if then, right? If P, then Q. So for these, it's P if and only if Q. And there's something special about that we're going to talk about today. So this means if P, and that should say then Q. So I just had to add my little N in there. And if Q, then P. So it has a double meaning. It's a biconditional. So you can think of that first part, bi, right? That prefix bi means what?
Two.
Means two, right? Like a bicycle has how many wheels? Two. A biconditional is going to be true forwards and backwards if it's a true statement. Okay, so that means it is going to be if P then Q and if Q then P. Okay, so it's going to be both of those.
Thank you.
Yep, if Q then P and if P then Q. Yeah. And then, so a biconditional statement is a combination of the conditional and the converse. Remember, the converse is if Q then P. The conditional is if P then Q. It is also written as P, and then this would be said if and only if. So IFF means if and only if. Okay, so instead of writing out like if and only if every time, if you see an IFF, that's what it means. Okay, it's not a typo. Or it's not if, as Jay likes to say. Okay, so what we're going to do is we're going to write the conditional statement and converse within each biconditional. So for part A, it says a solution is neutral. That's another way you can say if and only if. It's the double-sided arrow. So that double-sided arrow means if and only if its pH is 7. Okay, so I'll help you with the first one, the conditional. So we're going to start off by saying if a solution is neutral, then its pH is 7. If a solution is neutral, then its pH is 7. Notice that I underlined the P, the hypothesis, and I underlined the Q. And why don't you see if you can write the converse? Okay, so the converse is just going to switch your hypothesis and your conclusion. Tony, what are you thinking for that one, for the converse?
If its pH is 7, then the solution is neutral.
Yep. Okay, so if its pH is 7, then the solution is neutral. You can also, I talked about this earlier, if you want, instead of saying if its pH is 7, remember in English we like to say the modifier first before you start to use a pronoun. So you could also say if the solution's pH is 7, then it is neutral. Okay, so instead of using the pronoun first, I just use the subject first. Okay, and then I'm going to have you give B a try. So B says an angle is obtuse if and only if its measure is greater than 90 and less than 180. Okay, so see if you can write the conditional. Okay, and that is going to be one of ours. So this is our if and only if. Let's use the first statement as our p-value. So an angle is obtuse, that's going to be the hypothesis. And then its measure is greater than 90 and less than 180. This is going to be our Q or our conclusion. Okay, so for my conditional, I would start with if an angle is obtuse, then its measure is greater than 90 and less than 180. And then Sam, for what you said, I would put that for the converse. So if the measure of an angle is greater than 90 and less than 180, then the angle is obtuse. So for these, you can always start with whatever comes first as your hypothesis, which is a little bit different than what we were doing before, because before we always had the hypothesis come after what? We always had it come after if. Now your hypothesis is going to be in the front. Your conclusion will be in the back of your sentence. Okay, how did we do with B? You did good? All right, so for our next example, it says for each conditional, write the converse and a biconditional statement. So if two angles have the same measure, then they are congruent. Go ahead and write the converse. It's something you just did on your quiz. And Brianna, will you remind us what the rule is for the converse?
Just switch the hypothesis.
Good, you're just gonna switch the hypothesis and conclusion. So you should have if P, then Q. Okay, Caitlin, what'd you come up with for that?
I said if two angles are congruent, then they have the same measure.
Okay, so if two angles are congruent, then they have the same measure. Great. And for mine, I just abbreviated congruent. Yeah, Rob.
I was missing this.
Oh, okay, yeah, the biconditional. Okay, tell us what you put.
I said two angles have the same measure if and only if they are congruent.
Good, okay, so two angles have the same measure if and only if they are congruent. And really, because that's the start of the sentence, I would write out two TWO. Two angles have the same measure if and only if they are congruent. And notice that instead of writing out if and only if, I put IFF, which means if and only if. Okay, if you are going to use that abbreviation IFF, don't forget the two F's, because then that would mean something different. Okay, so for the biconditional, you can go ahead and you can take the hypothesis, and then instead of the then, you can think of it as you're replacing it with if and only if, and then you would end with the conclusion. Okay, so you basically just take out the if and the then, and in between them is where you're going to put the if and only if. Okay, let's try part B. Okay, so Tanner, do you think you got the converse written?
I said if x equals 9, then 5x minus 8 equals 37.
Good. If x equals 9, then 5x minus 8 equals 37. Okay, and then your biconditional, does anybody think they got that one? Yeah, Brendan?
5x minus 8 equals equals 37 if and only if x equals 9.
Yep, perfect. Okay, good. What questions do you guys have for me on the biconditionals? It looks like some of our copies got stretched out, right? Do not know how that happened. Okay, so I know yours looks a little bit different, but the first word is for. It just looks a little weird. Okay, so for a biconditional statement to be true, both the converse and the conditional must be true. Okay, so both the conditional and the converse have to be true in order for the biconditional to be true. Okay, so for our next example, we're going to determine if each biconditional is true. If it's false, we're going to give a counter example. So for part A, we have an angle is a right angle if and only if its measure is 90 degrees. I want you to write the conditional and the converse. When you guys are writing your conditionals and your converses, you are starting a sentence. And what do sentences start with? A capital letter. So why are we writing lowercase ifs here? Because why?
Because we're illiterate,
Yep, you gotta use proper English all the time.
That's how.
Hey, so go ahead and edit if you need to. Hey, Avery, what did you have for your conditional?
Oh, God. An angle measure is 90 degrees if and only if it's a right angle.
Okay, so that's going to be the converse. The conditional start the first one with the. See how this is going to be your hypothesis, an angle is a right angle?
Yeah.
Okay, so for the conditional, it will be if an angle is a right angle, then its measure is 90 degrees. Okay, if an angle is a right angle, then is its measure 90 degrees?
Yes.
Yeah, so that's going to be true. Okay, and then what Avery gave us was actually the converse. So if an angle measures 90 degrees, then the angle is a right angle. Is that true? Yes. Okay, so if an angle has a measure of 90 degrees, then it's a right angle. That's also true. So the rule is, if both of them are true, the biconditional is true. Okay, so if both of those are true, the biconditional is true. So next to the whole entire statement, I have true. Okay, so conditional is true, converse is true, the biconditional is true. If one of these is true and one of these is false, what do you guys think the biconditional is?
False.
False. Okay, so, and obviously if both of them are false, it would be false. So even if one is true and the other is false, the entire biconditional would be false. Okay, let's try B. So write your conditional and your converse. Okay, Caitlin, what do you put for the conditional?
That if y is equal to -5, then y squared is equal to 25.
Okay, so if y equals -5, then y squared equals 25. Is that true?
Yeah.
Yep, okay, and then, Kaylee, what about the converse? What did you write for the converse?
Y squared equals 25 if y equals -5.
Okay, so if y squared equals, 25, then y equals -5. Is that true? No, why not?
Because
Five
five
is
is
five.
Because
Okay, so
Positive
+5 would also make 25. So that is going to be false, and then it says if it's false, give a counterexample. So your counterexample would be y equals 5. Okay, and if you had 5, y squared would equal 25, but y would not equal -5. Because remember, whenever you do a counterexample, hypothesis is true, conclusion is false. Okay, hypothesis is true, your conclusion is false. Okay, and then for the next part, it says a good precise definition can be used forward and backward. Okay, a good precise definition can be used forward and backward, which is very similar to our biconditional, because a biconditional is true only if it's true forwards and backwards. Oh, and for the last one, did we put false for the whole thing? Okay, so you have a true, a false, and so the whole thing is false. Alright, so a good precise definition can be true forward and backward. So our example is if a figure is a quadrilateral, then it is a four-sided polygon. If a figure is a four-sided polygon, then it is a quadrilateral. So to be sure the definition is precise, it helps to write it as a biconditional statement. So what we're going to do is we're going to write each definition as a biconditional. The first thing we're going to do is write the first one. Okay, so for this one, we would say a figure is a quadrilateral if and only if it is a four-sided polygon. Okay, so a figure is a quadrilateral if and only if it is a four-sided polygon. And we're going to change A so that it says polygon. So it says a pentagon is a five-sided polygon. Okay, a pentagon is a five-sided polygon. So to make this into an if and only if statement, we are going to use the word figure. It should say a figure is a pentagon if and only if it is a five-sided polygon. So this is another one where you kind of have to add some of your wording in. So a figure is a pentagon if and only if it is a five-sided polygon. So based on that example, I want you to give part B a try. right angle measures 90 degrees. How should we start that? A right angle measures 90 degrees. Yeah.
A figure is a right angle.
Okay, good. So you could say a figure is a right angle, or you could also say if an angle is a right angle. So either one of those would be perfectly fine.
So the double-sided arrow stands in for IFL?
Yes. Okay, so another way you can write the if and only if is with your double-sided arrow, which is what I did here. So an angle is a right angle if and only if it measures 90 degrees. How do we do on that? Good? All right. I'm going to give you your homework to write down. And then once you have that written down, clear everything off your desk except for a correcting utensil. And we are going to go over our quizzes.